Okay, so thank you all for coming. Who am I? My name is Jonathan Berkhahn. I'm a software engineer that works for IBM, but I'm also a maintainer on the Service Catalog, or the Service Catalog SIG. Here today to talk to you about Service Catalog. Now, hopefully you all attended the intro on Tuesday, because I'm going to be making some assumptions about at least a basic working knowledge of what Service Catalog is and why you would want to use one. That said, what is this talk going to be about? So I'm going to start by going in a little bit more in depth about OSBAPI, the Open Service Broker API. Exactly how do we use it? What are some of the underlying cruft, how it works? I'm going to talk a little bit about how we've architected Service Catalog, what the thing actually is, how it works, some of the design challenges we've faced in implementing it and upgrading it. Then I'm going to sort of talk a little bit about what we, the SIG, have done recently, some features we've implemented recently. And I'm going to finish up by talking about what our plans for the immediate future are. What is this talk not going to be about? So like I said, this is not going to be an introduction to Service Catalog. I'm kind of going to come in here with some assumptions that you already know. Why would you want to use Service Catalog? Why you would want to use it in connection to your apps running on Kubernetes? And at the same time, I'm also hopefully not going to get into too much of the nitty-gritty implementation details. We don't really have the time or space to do that here. That said, if you are interested in the nitty-gritty implementation details, please feel free to come up and say hi to me after the talk or show up to one of our SIG meetings. OK, so going to get right in. OSBAPI, as we like to call it, the Open Service Broker API, is a specification for a spec, or an API, that allows the automated deployment, management, and use of services. And what do I mean when I say services? I don't really mean it in the Kubernetes sense. This is more of a generic something that runs somewhere and is accessible at a web address. And what it does is pretty much up to the, left as an exercise to the user. It could be sort of the archetypal example we use is a relational database. So you have some app that's a cloud-native app, 12-factor app, doesn't have persistent anything, needs some place to store your data. So wouldn't it be nice if someone would deploy a database for you so you didn't have to manage it or you care? So that's sort of the archetypal example of what OSBAPI is trying to solve, to abstract the creation and management of that database away from the app developer so they don't have to know or care or worry about it. That said, it can be used for a lot of other things. It could be used for, like I said, a relational database. It could be used to manage subscriptions to some sort of public-facing API that you need for your app. So that could be something like a message queue or a payment service or anything. It could be something even more complex, like an auto-scaling service, which reaches back into the platform that your application is running on and scales your app that's using the service up and down dynamically based on your workload. So anything that can be decomposed into the endpoints could be written as an OSBAPI service, and that versatility is kind of one of the strengths of why we're hoping to get people to use Service Catalog. Literally speaking, like I said, it's an API, so the client side of the API is implemented by Service Catalog. That's what we do. The server side is implemented by a service provider as a broker. So this could be one broker that provides a specific service, like Jonathan's MySQL database shop. A lot of the large cloud providers like Google or Amazon implement a broker that plugs into all of the available services on their cloud. So it's good for things both big and small. And the three endpoints we're going to be focusing on today, there's a couple more, but these are the important ones, are get catalog, provision service, bind service. So get catalog happens once at the very beginning when you register the broker with Kubernetes. So this says, hey, broker, what are all the services you offer? And it returns a list, and we should keep that and store that somewhere. And then when a user wants to create an instance of a service, we say, hey, broker, provision me a service, and we pass some data along with it. And then when something actually wants to use that service instance, we create what's called a binding. So we say, hey, service broker, create us a binding for that service instance we told you to create a little while ago. And it'll be like, OK, and give us some credentials that we can use to access that service. This is what the resource types that we have implemented look like. So it's a collection of 5 resource types that correspond closely with the internal abstractions that the OSB API uses. So we have a cluster service broker. It's a cluster-wide resource that represents a single broker running outside the cluster somewhere. For an example, MySQL broker. Cluster service class is a single category of services offered by that broker. So in this continuing example, that service class would be MySQL databases. And then that class will have one or more service plans. And these can be different flavors, different SLAs offered by that service. So in the example of MySQL databases, that could be different sizes of MySQL databases offered. It could be different SLA guarantees, like this one's guaranteed to be replicated 5 instances across 2 AZs, whereas this one's a single instance running in one place. That's really up to the broker author and how to use that, what different plans they want to offer to the users. A service instance is a single instantiation of a specific class and plan combination. So if I want to go and create a MySQL database, I would provision an instance, call it Jonathan's 100 MB MySQL database, because that's the plan and class I chose. I would go talk to the broker would create that doing however it wants. It's really not up to the platform to care about how it actually does what it does. So this could be provisioning MySQL databases on bare metal machines that are in a database somewhere. This could be carving off a slice of some giant cloud database somewhere on the internet. I don't really know. I don't really care. It's not my problem. And then when I actually want to access that database to read and write data, I need to create a binding. So I'll be like, hey, broker, create a binding to this thing, and it'll spit back a unique set of credentials to access that database. In the case of this example, that's probably a URL import where that database is running, and then maybe a username and a password, or a username and a token, or something like that. But that's, again, up to the broker author, so that could be pretty much anything. But username, password, URL, that's pretty standard. So again, I'm just going to walk quickly through the workflow, try and take some of the magic away of how this actually happens. So you have your Kubernetes running, and someone, probably an admin, this probably isn't really a user app developer level operation, is going to register a service broker with your Kubernetes running service catalog. So we're going to go out to wherever the broker is running. We're going to hit that catalog endpoint. And that broker is going to return back some catalog of services that it offers. And we're going to store that locally so that when a user wants to provision services, they can see that. So some user is going to say, create me a service instance. We're going to go and ask the broker, hey, create service instance foobar. And it's going to provision something in its backend and return, yeah, that thing's been created. The user then is going to deploy some application on Kubernetes. So this is a pod running somewhere, running their application, doing whatever they want. And then the user is going to create a binding for that service instance. So we're going to talk to the broker, create a binding. It's going to give us the credentials back, and we're going to insert that in a Kubernetes secret somewhere. The user then is going to attach that secret to their app however they want. And then the app can then consume the credentials in that secret to go and talk to the actual service instance. So that's sort of the workflow from beginning to end. OK, so now I'm going to take a step back a bit and talk about some of the design issues that we've faced while creating Service Catalog. Service Catalog is kind of in a weird spot because it's a Kubernetes incubation project, but it's also been around for a while. It's coming up on, I think, our 2-year mark at this point. So a lot of the things that the extension points for Kubernetes that are available today didn't exist when we started working on it. So for instance, one of the first questions we get usually is, why don't you use CRDs? And that's because, well, CRDs didn't exist when we started. TPRs existed, but were kind of weird and janky, so we didn't want to use them. So what we ended up doing is we wrote our own API server. We extended the API server offered by API Machinery, defined our own custom resources. We usually run our own etc to store all our junk in, which was decided mostly for security reasons. They didn't want us to have access to the main kube etc running for us to store our junk in. And then we use API aggregation to sort of suture ourselves into the kube API server namespace, so that whenever the main kube API server receives a request for one of our resource types, cluster service broker, those things I showed you earlier, it just forwards the request to our API server and we handle it. So this allows seamless interaction with our resource types as if they were mainline Kubernetes resource types. You can interact with them with kubectl, create them, delete them, update them, just like you would any normal Kubernetes resource. Although we have a CLI for some custom interaction, I'll talk about that in a minute. The other issue is we're sort of at a unfortunate cross point between two APIs, sort of the main like Kubernetes way of doing things and OSBAPI itself, which has led to a couple problems. One is GUIDs versus names. So in Kubernetes, names of objects are fixed and immutable. You say this is the name of this object when it's created, and that's it. You can't change it, can't be updated. If you create something with a different name, that's an entirely different resource. In OSBAPI, things are a little bit different. Names are subject to change. Also, each resource has a couple different things that could be considered the name. They usually have an external name, which is something human readable, and then they have an ID, which is a GUID, which is more how you're supposed to refer to it. So it's kind of confusing. Each of our resources kind of has 3 different things that could be considered the name. That was one of the impetuses behind writing our own CLI as SPCAT, because we really want users to interact with the external OSBAPI names of these resources rather than the Kubernetes name, because they don't really necessarily care that they're interacting with MySQL foobar XYZ class. They just want a MySQL database. So that's probably what the external name is going to be. That's probably what they actually care about. And this is just sort of an ongoing point of contention for us additionally, because the restrictions enforced on Kubernetes names and the restrictions enforced on the OSBAPI equivalents of our resource types are different. So we are constantly keeping up with those, trying to translate them and make sure they play nice with each other. In addition to that, because we interact with these brokers, which are external to Kubernetes entirely, we can have some issues with synchronization. A user goes to Kubernetes and says, update this resource with this field, and Kubernetes is like, yes, you're allowed to access that resource, done. Eventually, the world will come to look like what you wanted. And that's good in main Kubernetes because Kubernetes is the master of its own domain. It can change anything it wants to. However, with us, we're subject to the whims of the broker that we eventually have to go and talk to, which it might not necessarily agree with what you asked it to do. This is sort of ongoing contention, especially with things like delete, which are not rollbackable. So like I said, this is just sort of an ongoing point of contention with us. A couple things in our API are sort of not very kube-like. They sort of follow a more imperative flow because we're subject to what the broker allows us to do or doesn't allow us to do. So this can be kind of weird when interacting with some of our resource types. Again, like I said, we implemented our CLI to sort of obfuscate this away to from the user, so the user doesn't necessarily have to care about a lot of these directly. OK, so now I'm going to jump right into some of the recent work we've done as a SIG. So first I'm going to talk about service curation. So because our resource types are global, for instance, we only have one resource type called service classes that's used to represent all service classes available on the cluster. So this could be MySQL databases, MongoDBs, Postgres SQLs. All of the various services offered on your cluster are represented by this one resource type, which means RBAC can't easily manage access to a specific subcategory of services. Because you either have access to all the service classes or none of them or whatever. So to make it easier for cluster operators to restrict or grant access to specific things, we've implemented a couple features. Namespace brokers and catalog restrictions. What does that mean? OK, so this is what a normal cluster service broker looks like. I have 2 service brokers, each with 1 service. Each of those service is represented inside Service Catalog as a cluster service object that is visible to all users. And if I were to restrict access to cluster services, I would restrict access to both of these. But that's not what I want. I want user A to be able to see service A and user B to be able to see service B. So there's already a mechanism in Kubernetes that restricts visibility per users like this, and that's namespaces. So we've created the ability for users, or operators, I should say, to register service brokers in specific namespaces, such that those services are only visible to users of that namespace. So here I've registered the first service broker in namespace A, so only user A can see it, and same for service broker B. So that's nice. It uses a resource that a lot of Kubernetes users and operators are already familiar with. But it's kind of cumbersome if you really want to restrict like something cluster-wide. So we also implemented catalog restrictions, which is simply at register time, when you're creating the broker, when you're adding the broker to your cluster, you can add a set of basically white or black lists to filter its catalog. So here I've registered a service broker, which offers two services, service A and service B. When I created that broker, I said, no services named B. So it doesn't even show up to any of the users. This isn't necessarily namespace scope. This is global, wherever anybody can see this broker. And then we also have, I guess this one's whitelisting. So if I register a broker, I'm like, I only want service A specifically, drops all the other ones. So combined, these two features allow a rich feature set. There's a lot of possible permutations using these two to allow cluster operators to expose only certain services or certain categories of those services to certain users. All these examples were based on service classes, but it's also applicable to service plans for even more fine-grained control. All right, and SPCAT. So I've been talking about this a bit. SPCAT's a CLI tool we implemented and made available to users. It's in the same repository as main service catalog. It's a CLI that basically allows for CRUD of our various object types. We've tried to follow sort of a Kubernetes-esque feel of control flow. But like I said, there's a couple extra commands and a couple extra things we do that make more sense for our sort of problem domain, like marketplace. So if you're on a cluster with Service Catalog installed and you want to see what are all of the services I can buy, that's sort of a combination of both classes and plans and a couple other object types, but I'm not going to mention those in the moment. So it can be hard to get a picture of all of the things you can get using just kubectl, because you'd be like, kubectl, get me the classes. OK, but what plans do those classes have? OK, I'm going to go get the plans, but now I have to figure out how those plug into each other to see which things I can get. So we wrote a marketplace command that just throws up all that information in a human-readable format so you can easily see what are the things I can get. So in this case, this is just a very simple marketplace example. I've got MySQL DBs and MariaDBs and some various plans. So I can easily see the stuff I can get. Future plans. So I mentioned CRDs didn't exist when we started implementing our thing. That's not to say that we aren't interested in them. We're trying to get a couple features out the door at the moment, so that's currently next on our list of things to do. It seems promising, and in the event that we do switch to CRDs, it should be fairly seamless. So currently we have an API server and a controller that we implement. Assuming we can replace our resource types wholesale with CRDs, that would just sort of allow our API server to fold away and be fairly seamless upgrade path. I also mentioned synchronization issues between our Kubernetes and our brokers. That's sort of an ongoing source of interesting and exciting problems, so we're always working on that. Default parameters. So right now, all of the classes and plans that are available to our users are just direct translations of the ones offered by the brokers. We're working on allowing operators to specify different permutations of those classes and plans. So it could like pre-specify stuff that's configurable on the broker, but like pre-specify it so the users don't even have to care about that. So it's pre-configured for them to allow sort of to create shadow classes or shadow plans that the user would see as the same as any others. Pod presets. So this is something we've been working on and off for a while. We'd like for there to be something that when a binding is created automatically injects the secret into a pod so that the user doesn't have to actually go and manually attach that. It's a problem for a couple different issues. We basically need to change some stuff in mainline Kubernetes to make that possible. So we're sort of going back and forth with some of the core Kubernetes SIGs to make that possible. Also, we are technically still a beta project. We are not released yet, but that should be happening hopefully next year, coming up in the very near future on our 1.0 release. OK, so that's pretty much all the material I have. I'm going to go ahead and drop a couple quick links. So the first one, spcat.io. That's our documentation page. If you're interested in using Service Catalog, interested in writing a broker, interested in contributing to the project, that'd probably be the best place to start off. Second after that is our GitHub repo. So that's where all of our actual junk is. And then the third is the Open Service Broker API page. So if you're interested in just how the API actually works, or what it is, or if you want to write a broker, and that would be the best place to go. And then finally, I'd like to invite everyone, if you're interested in contributing or just use our thing and want to tell us how much it sucks, show up to our SIG meeting. It's every Monday at 1 p.m. PST, and that's the URL. So we'd be more than happy to hear from you. And now I'm going to field questions if anybody has any of those.
Yes, thank you. So question about the binding. And once you have a service, the service binding creates, let's say, have the address and the username and password. But across the life cycle of the service, you might change the password, for example. So have anybody thought about how can we have this binding remain the source of truth of accessing the service, especially around the credentials of accessing it, updating the credentials?
So that's sort of up to the broker. So every time you create a binding, it creates a unique, it's supposed to create a unique set of credentials. So that binding is not necessarily like a pointer to something existing somewhere outside. It's supposed to be its own sort of self-contained thing. There are people have expressed a desire for a live updated binding, but that has a couple issues just with the current way the API works. Sounds like Doug wants to.
Well, yeah, in the open source broker API working group, we have talked about credential rotation type stuff. We just haven't figured out the right way to do it yet, but it does come up quite often. So it is a requirement we are thinking about.
Because it ties back to putting it in a secret. So again, it's automatically put in a secret, which is awesome. But again, I want to make sure that that entire life cycle is updated, or somebody has to go in and manually change the secret after they change the password. And the whole idea is they don't see all of this process. It's just transparent for them. So
that's exactly why we haven't solved it yet. It's not an easy problem. Yes.
Hi. I have a couple of questions. One is we're looking at our company for something that will be able to hold all the services, not just the sort of platform managed services. So looking out, we saw references on the Pivotal website to user-defined services. So for example, we might not only be using a cloud provider services, but we might want a mechanism for registering everything available within the enterprise, and then potentially getting users to be able to bind in the same way to those enterprise-specific services. So I was wondering if you have looked into anything like that as a use case.
So that's an excellent question. I'm going to back up a bit, and just for the benefit of everybody. So he mentioned something called user-defined services. So this is sort of a secret, run around the end sort of pocket case of OSBAPI. So user-defined services are a thing that originated in Cloud Foundry, where rather than registering a broker, it spits its classes and plans out at me, and then I create a permutation of those classes and plans. What if I were to create a service instance that didn't have a class plan or broker? And the most common use case you'd want to do this is, say I have some legacy thing, maybe a database that has all my legacy data in it. I want to be able to manage it using the OSBAPI lifecycle, but I don't have a broker for it, and it also pre-exists somewhere. So I want to be able to create a service instance that points to that thing, but doesn't necessarily have like a broker managing my interaction with it. And the answer is yes. That's currently something we're actively working on. The PR is open. It's going back and forth. So that's definitely something we're interested in, and it's something that's going to be available in the very near future.
Thanks. And if you don't mind a follow-up question, the other thing we were interested in, that by the way, hits the nail on the head. That's lined up with what I'm talking about. So then what about being able to do more kind of client-side declaration of dependency and or discovery against that? So for example, what we'd like to do within our company is be able to locate the appropriate service instance, say in a given realm or environment, based on certain properties that might be a little fluid, kind of label-like properties. So is that clear yet? So in other words, based on ways that the user, an app characterizes their need, like I need a high memory thing or a low memory thing, which would be a property that could be registered kind of like a parameter, and or system context, like this happens to be the dev environment or the prod environment, that those kinds of labels could be used like a selector to find the right service instance.
So the problem with that is that the service instances ultimately aren't up to us, they're up to the broker. And like channels we have for communication with the broker are relatively limited. It's been a topic of discussion in the OSBAPI working group about something like that, being able to tag things with specific things that are like meaningful across brokers or across platforms. But we haven't come up with a solution to this problem as yet. I think Doug has a little bit more to offer on that end.
If I understand your question properly, you want to be able to, in essence, parameterize your provision operation. There is a field on the provision API itself where you can pass in additional parameters, exactly for the user to specify things like, I know I need special configuration for this particular instance. There is a mechanism to pass that all the way through to the broker as it gets provisioned, yes.
But it's
So now, thanks. So I saw that part. Now I want to be able to kind of search for it on the consumer end and locate the right instance.
You want to take that, or should I? Are you
You
done?
can take it.
Okay, yeah, I think that's going to be a platform-specific issue. Service Catalog itself doesn't necessarily have that feature right now. When you want to search through the list of service instances that are there, you basically have to look for it by name that you gave it. It is technically a resource inside Kubernetes. You could technically add your own labels if you wanted to, but that gets a little bit dangerous because you're mucking with someone else's, managed, Service Catalog managed data at that point, but it is technically possible. Usually you just search by name more than anything else, but you could twiddle it if you really wanted to.
And I should have mentioned this earlier. Doug, my esteemed microphone monkey, is one of the chairs of SIG Service Catalog and also a member of the OSBAPI working group. So,
is the SIG interested in or looking at creating ontologies of services? The things which are compatible with MySQL APIs, or the services which are relational databases, or any kind of ontologies?
So, like I said, the problem with that is a lot of the stuff required to do something like that is sort of on the broker end, and we don't necessarily control the brokers or the broker authors. That is a topic of ongoing discussion in OSBAPI land about being able to say, like, this is a MySQL broker and have that mean something across brokers and across platforms. But as of now, I don't think we have any concrete solutions to that sort of problem.
Yeah, the closest we've come to that, as Jonathan was alluding to, was the notion of when a broker advertises itself, it could say what specification this service adheres to. So you could say, oh, it adheres to MySQL 1.0, and that way the user, when he looks at that service, can know exactly what kind of operations are available to it, and it sort of gets into that ontology type thing slightly that you're talking about. I don't know how I'm going to reach you. There you go, thank you.
Sorry, Sam. So during, this conference so far, there's been a lot of talk about operators, and I know that AWS have provided, they've recently written the AWS operator, so to create elastications, DynamoDBs and stuff like that. What would be the way that you guys are pushing for to create custom resources? Would that be with Service Catalog, or would that be with Kubernetes operators instead? I don't know if that makes sense.
I think Doug's gonna have to feel this one. That one's a bit out of my wheelhouse.
So I think there's a lot of confusion between operators and service broker stuff. And I'm not an operator expert. I've only read about them actually more over a year ago, so I could be getting it wrong. But the way I kind of view operators is it's a mechanism to deploy, in essence, another Kubernetes application inside of your cluster to manage other things, okay? Service broker is about talking to services, typically services that are outside your cluster, because Kubernetes already has a mechanism to connect your app to a service running in your cluster. So this is more about talking to something outside your cluster. Operators are running inside your cluster. So they're almost two different worlds, and I'm not quite sure why people are mixing the two. Maybe that's why I'm misunderstanding, because I don't see the connection.
Right, so the thing I was referencing was that the AWS operator does let you create things like DynamoDBs, and so we've written a OSP provider that, for instance, gives you a DynamoDB. So it's the cluster service class there would be like a DynamoDB, for instance. And then every service instance you create would give you an instance of a DynamoDB. And we're kind of thinking, oh, well, if there's an operator for AWS that can give you DynamoDBs as well, then it's kind of the same thing, if that makes sense.
Okay. So thank you. That's actually refreshing a little bit of my memory about why I even looked at operators to begin with, because someone did mention the overlap, and I remember talking to somebody over at CoreOS when they first came out with it to see if there was some way to sort of merge the two worlds slightly. And the general consensus I got back was not so much right now anyway. And I don't know if it was because they didn't want to merge the two worlds because they wanted their own thing versus our own thing, or whether there really was a functional difference. I can't answer that part of the question, unfortunately. Wait, you got to get you on tape.
Oh yeah, at least if you are going to CRDs in the future, that would be good to have some kind of convergence there. Yeah.
Keep in mind, these CRDs are just for managing the metadata that Service Catalog is keeping track of. It's not CRDs for the service itself. It's Service Catalog's metadata. So it may be slightly different.
When do they kick this out?
I don't know. That's right.
Well, I was just curious if you could go into a little more detail on some of the synchronization problems you guys are seeing and some of the solutions you're looking at for those problems.
Sure, so I can talk about the nasty one, which is irreconcilable delete. So when you delete an object in Kubernetes, it marks the deletion timestamp, and then things start happening all over the place. So in our world, that's a problem because I can say, I'm going to delete service instance foobar. And it goes, you talk to the etcd, it says you're authorized to access this object, this resource, mark the deletion timestamp, done. And then we go and say, hey, broker, delete service instance foobar, and the broker says, no. What are we supposed to do? And that can be a problem for multiple reasons, because that now the state in Kubernetes, we can't roll back from the delete. Perhaps this user is still getting charged for this thing that still exists on the broker end. And like I said, the irreconcilable delete problem, we don't actually have a working solution for it right now. Some of the solutions we've proposed are, like I said, implement non-Kubernetes-esque things, like intercept all incoming delete requests to, instead of actually marking the delete timestamp, mark a flag called to be deleted on the object spec, and then have our own custom controller logic that eventually results in the deletion timestamp being marked for real. Things of that, like I said, it's sort of a source of ongoing discussion. Aren't really any clean answers, unfortunately.
You have two-way synchronization problems effectively, of which changing and rolling passwords from the broker side back is probably another variant of that effectively. So.
That has an additional problem in that currently under the OSB API spec, brokers are intended to be implementable as stateless machines, which means the broker, unless you like, hey, I'm talking about binding XYZ, it doesn't necessarily have to know what you're talking about. It doesn't really keep a running track of all of the bindings it has active at that time. So yeah, life's rough. I think we had another one.
I was just curious from end user perspective. I know you said you all are in beta, but are you seeing adoption? Are people like rolling this out to internal teams or anything
so
like
we
that
are
at this point?
currently a beta product. However, there are a lot of actual production clusters that already use Service Catalog. So I myself, I work for IBM. IBM Cloud, private, I believe, uses Service Catalog, and we're currently rolling it out for our public cloud. Red Hat OpenShift, I know uses it. I don't exactly know all the different flavors of OpenShift, but I know they use it in production. Microsoft Azure uses us for they have their own Azure broker. And Google, I believe, currently still uses us. That's kind of up in the air at the moment.
Cool, thank you.
I think Doug has some more comments.
I've heard rumors that AWS actually uses it too, at least internally, if not externally. I heard rumors of them using it internally as well for their stuff. Rumors, though. Can't guarantee that. Yeah.
Okay, anybody else? Okay, thank you all for coming.